For those preparing for complex analysis exams, here we go. I've decided to do this video starting with these midterm exam papers since I have found the same questions in the final exam papers that I will be showing you in a while. But let's look at this paper. Number one says you determine whether the following functions are analytic. Oh, for a function to be analytic, it must satisfy Cauchy-Riemann equation. Of course, if you are in this area of math, you should know what we mean by Cauchy-Riemann equation. So let's start with the first one. W, this function W, which is given by 2xy plus ix squared minus y squared, is given as a problem, and we are to determine whether indeed this function is analytic or not. So let's go ahead and do that. Okay, so let's pick our pen and see whether that function W, it is given as W 2xy plus I into x squared minus y squared is analytic. The very first thing you need to know here is that this question have got both the real and the imaginary part. So we usually represent the real part with U and then the imaginary part with V. So this is the real part, and this is the imaginary part. So our U in this case is given as 2xy, and our V, which is the imaginary part, is given as x squared minus y squared. So let's go ahead and differentiate this in respect to x. So we want to do partial u, partial x, that is dou u dou x. When you do dou u dou x, what you get here will be 2y. Of course, this is differentiation, and having done this, let's now do dou u dou y. Dou u dou y, in this with u, we are still differentiating in respect to this u. This will give us 2x. In this case, this is 2x, and then we want to also do dou v in respect to v. Dou v dou x. Dou v dou x, here we will simply get, if we differentiate this in respect to s, we get 2x. Let's also differentiate that in respect to y. Dou v dou y will simply give us negative 2. We want to differentiate in respect to this will be negative 2x. That is negative 2y. Sorry for that, negative 2y, because we are differentiating in respect to y. Dou v dou y will simply give you negative 2y. So now that we have done our differentiation, the next thing that we want to do is to check with Cauchy-Riemann equation. We want to check the Cauchy-Riemann equation. And you should know this equation by heart. What this equation says is that dou u dou x must be equal to dou v dou y, and then dou u dou y, this is dou u dou y, must also be equal to negative dou v dou x. So you must know this Cauchy-Riemann equation in your head for you to be able to determine whether indeed whatever we are saying here is analytic or not. So now let us look at what we have here and see whether they satisfy the Cauchy-Riemann equation. We know that we have differentiated dou u dou x, we differentiated dou u in respect to x, and what did we get here? We got 2y. This is equals to 2y. And we also differentiated in respect to we differentiated dou v in respect to y, dou v dou y, and what did we get? Dou v dou y here we got negative 2y. We got negative 2y. And then we also differentiated dou u in respect to y, dou u dou y, and what did we get? We got 2x. And then we come back and we differentiated negative. We come and differentiated negative dou v, because here we have negative dou v dou x, negative dou v in respect to x. And what do we get there? We get 2x. 2x. We got 2x. Okay. Let's see. Here we have got dou u dou x. Dou u dou x must be equal to dou v dou y. Here our dou u dou x is 2x and our dou v dou y is negative 2y, which means the first one is not satisfied. Here we have also come and we see dou u dou y. Dou u dou y is 2x, and then negative dou v dou y, this is supposed to be equals to negative dou v dou y dou x, and in negative dou v dou x we've got 2x. This is okay because it is satisfied. This is 2x and this is 2x. Dou u dou y is 2x, negative dou v dou x is also 2x. But come back here, you will see that dou u dou x is 2y and dou v dou y is negative 2y. So this has failed. So even though the first one failed and we got the second one, we cannot claim that this function is analytic, since it does not satisfy Cauchy-Riemann equation. So what we can conclude by saying is that w, which is the function that we are given, w is given as 2xy plus I into x squared minus y squared. This is the function that we are given. So these functions are not analytic. They are not analytic. They are not analytic because it did not satisfy the Cauchy-Riemann equation. This is because Cauchy-Riemann equation are not satisfied. And this is how you can handle this type of question, whether a function or not analytic. First of all, you need to find what is your real and what is your imaginary part. When you discover the real and the imaginary part, partially differentiate the real and the imaginary part, then subject your differentiation to Cauchy-Riemann equation, and if your differentiation did not agree with Cauchy-Riemann equation, then the function is indeed not analytic. But when it satisfies the Cauchy-Riemann equation, then it is indeed analytic.